Okay, we are now recording. Let me get my pen set up. Okay. Just a couple of other announcements to make, and those are: first, they have opened the student course evaluations now, so you can do student course evaluations. I highly encourage you to do so. We really benefit from those. I benefit from looking at them, both mine and other people in my department. That's partly how I evaluate them. It's how the school sees if we're doing a better job. Things like, the library services, food services, or registration practices, they don't have very much input except for those surveys. So please do the surveys and get those done before the end of the term. You can wait until you see the final exam and that kind of stuff, but the trouble with doing that, you might, at the end of the term, have so much going on and under so much pressure and stuff, you forget to go back and do the survey. So I suggest you do it earlier, but if you can remember and will remember to do it, you can wait till the end and do it then. It doesn't matter to me. I just want you to make sure you've done it. So please do the surveys. Second issue is a little matter of my office hours. Today is normal, 3:15 to 5:15, so no problem there. However, tomorrow, normally I have office hours from 10:45 until 1:15. And the reason I have them then is I usually eat in my office, okay? So I can have my office hours while I'm in there eating and whatever. However, tomorrow I've got a meeting with some others that we're eating off campus as sort of a working lunch type deal. And I've got to leave campus. The lunch is going from 11:15 to 1, so I'm going to have to leave campus not much past 11 to get there by 11:15, and then I'll be hoofing it back here as soon as I can after 1 o'clock for my 1:15 class. So if you need to see me tomorrow, try to make it as close to 10:45 as you can before I leave campus, as close to 1:15 as you can once I get back from campus before my class starts. Or, and here's the bright side of this, in my physical science class tomorrow we have lecture for 2.5 hours, normal, and then lab for 2 hours, normal, except I don't think the lab will last 2 hours. So from 3:45 to 5:45 we're supposed to have lab. I'm pretty sure we'll be through by 5 o'clock, maybe even a little earlier, but definitely somewhere around 5. So if you can't catch me right after 10:45 or just before 1:15, try to catch me sometime around 5-ish or so. If I'm not through with lab, I will be finished fairly soon. So that's that. All right, any questions on anything before we get started today? Okay. We are in Chapter 4, Higher Order Differential Equations, Section 4.4, Undetermined Coefficients Superposition Approach. And we're on page 140. We had just finished looking at some samples of types of functions that you could use this superposition approach. And if you can, and do, and will, then your g of x is a linear combination of functions of the type yuck. There's Matt. I didn't mean to say yuck when you came in, but the Silver's here. I forgot to mark you, and Matt's here. I've now marked you. Okay. It was all set up, ready to go, and my sleeve of my shirt hit something and had me go back. Okay, so. So what we were talking about is variety of, I'm sorry. Tied on some way. Okay. So you could have a function that g of x at the end, the inputs g of x, that are appropriate, and then the g of x is some linear combination of functions of these types. Now they say g of x and then call it p of x. Now I don't know why these are the various types of P of X that G could be a linear combination of these. And I thought I had already done this, but I'll do it again. Okay. You could have a polynomial function. That's what P of X usually stands for, and that would be a sub n, x to the n plus a sub n minus 1, x to the n minus 1 plus a sub n minus 2 times x to the n minus 2 plus dot 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 all the way down to a sub 2 x squared plus a sub 1 x plus a sub 0. Okay? You could have functions that look like that. You could have functions that look like this. Now, these are not polynomials here, but they still use that thing. That polynomial, okay, then multiplied by e to the alpha x, okay? Or that polynomial times p to x multiplied by e to the alpha x sine beta x, okay? Or p to the x times e to the alpha x cosine beta x, okay? Any one of those kind of forms, okay? You could have a polynomial times an exponential times a sine or a cosine, okay? And some of those, the sine and cosine, that may be plus that, okay? In other words, sine and cosine terms there, okay? Now, and by the way, n is a non-negative integer, meaning it could even be 0, but it can't be negative. Alpha and beta are any real numbers, and the method of undetermined coefficients is not applicable to equations of the form. You can't use it. You can use these. These are okay. You can't use these down here, and these would be equations where your g of x could be a log x. We just don't have any way to do that, okay? G of x equal 1 over x. Can't do that either. Rational functions are out, okay? G of x, even though we can use sines and cosines, we can't use tangent or even inverse functions. Inverse sine or cosine. We just don't have the capability of doing that. Only the ones, polynomials, exponentials, sines or cosines, okay? And any linear combination of those. If you have that g of x with a log x, 1 over x, tangent x, inverse sine of x, secant x, cotangent x, cosecant x, inverse cosine, no, none of those will work, okay? All right. So the set of functions that consist of constants, polynomials, exponentials, e to the alpha x, sines, cosines, that set of functions has a remarkable property that derivatives of their sums and products are again sums and products of constants, polynomials, exponentials, sines, and cosines. So you see, a log x, its derivative is 1 over x. It's not of any of those forms. 1 over x, its derivative is minus 1 over x squared, and they get worse and worse and worse. Tangent has secants in it, and secants have tangents and secants in it, and inverse sines have 1 over square root of 1 minus x squared, and all sorts of weird things in them. Not. These, though, at the top, polynomial functions, their derivatives are polynomial functions. Exponential functions, their derivatives are exponential functions, okay? Possibly with polynomials involved. And sines and cosines, their derivatives are cosines and sines. Various SIGN signs, but they go. Okay. So let's do example 1. General solution using undetermined coefficients. So let's go to this. Solve this. Y double prime plus 4y prime minus 2y is equal to 2x squared, sorry, minus 3x plus 6. Okay. Now, how do we do that? I don't know if we've talked about it enough that you're familiar with it yet, or if you need me to run through it. Where would you begin? Okay? Okay, before you do M, deal with the homogeneous part. Okay? So let's first do y double prime plus 4y prime minus 2y equals 0. Now do your M. And what will your M be? We call this a characteristic equation. What is it? M squared plus 4m minus 2 equals 0. Okay? You think you can factor that? Think again. Okay? Nah, I can't. I don't think you can either. Right? So if you can't factor, what do we do? Second? Quadratic formula. So that would give you M equal what? Remember how it goes? Do I need to write it down? Second? No, not yet. You start with minus b. Right? And what's your b? 4. Minus 4. Now your plus or minus the square root of 16 minus 4 times 1 times negative 2. Okay? All over. Second? 2 times 1. Okay? So what will this become? Minus 4 plus or minus the square root of 16. And 2 minus make it plus 8 over 2. And that would be minus 4 plus or minus the square root of 24 over 2, which can be simplified a little bit to be minus 4 plus or minus 2 square root of 6 over 2, and this 2 can go into 4 twice and into 2 once. So this will be minus 2 plus or minus the square root of 6. All right, there's your M, or your 2 M's. One of them with plus, one of them with minus. Okay. Now, what do we do with that? I'll put M1 is equal to minus 2 plus root 6. M2 is equal to minus 2 minus square root of 6. What do we do with that?
You set it up in your C.
Do what?
You set it up with your C1, 2.
Okay, and what would that be? So now, your C1s and 2s are constants, you're right, but there's C's involved with the other part too. We have 2 types. The homogeneous part is called the characteristic solution, which is a y sub c, which has c's in it, so don't get the c's crossed up. So your y sub c, the characteristic solution, if this had been homogeneous, this would be your solution. What would that be? C1 e to the minus 2 plus root 6 x, put that like this, plus C2 e to the minus 2 minus root 6 x. So that is your characteristic equation solution, whatever you want to call that. Okay? And there you have it. Now,
why did they have a negative pulled out of the parentheses?
they messed up.
Okay.
Yeah, that I see it now. I hadn't noticed it before. That parentheses should be outside that minus. Okay. Wait. Nope. That's perfectly correct the way they did it. You see, if I did pull out the minus here, that would be a 2 plus root 6, and that's what they got. So it's exactly equivalent to this. Okay. No, but theirs is correct because they have a plus after it. No special reason to do that. And again, if this were a computerized homework system, like WebAssign or something like that, and they wanted this answer, and you put that one, they'd say it was wrong. That's just as correct as this is. In fact, I like it a little better, I think. But, obviously, I would. Now, that's your characteristic solution, y sub c. The next step is then to come up with a y sub p, a particular solution. Okay? And that particular solution, because your g over here is a quadratic, okay, then we'll assume that your particular solution will also be a quadratic. Now, no special reason they use these, but they use capital A x squared plus capital B x plus capital C as your particular solution. Okay? Now, your particular solution has to also solve this, right? The left-hand side, right? So, let's see if it does. Y particular prime would be what? First derivative of y particular would be that's your y particular. What's the derivative of that? 2ax plus b. Okay? And we need a y double prime, so yp double prime would be 2a. X is the variable that gets reduced away. A is a constant. Okay, so there's your y double prime. Okay. Now, if we plug this back into your left-hand side, okay, your y particular double prime is 2a, so that would be 2a plus 4 times your y prime, which would be 2ax plus b, minus 2 times your y, and your y particular is a x squared plus, goodness gracious, plus bx plus c. Okay? I didn't write. Okay, yeah. Okay. So that's your y double prime here, plus 4 times the y prime from there, minus 2 times the y from there. Okay? Now, that's supposed to equal, and let's sort of combine some terms here. you have a minus 2ax squared plus 4a plus b x, right? There's your x squared term. Oh, that's a minus b, okay? Okay. Ooh. That's an 8ax. So that's not 4, that's 8. Four times 2 is 8a. Okay. I'm combining like terms here. See, there's no x squared here, but right there. So there's a minus 2ax squared. Now let's look at b terms. There's a b term, an x term, and there's an x term. Oh, I left off the 2 too. Goodness gracious. That's plus 8a minus 2bx. Okay, let me clean that up just a little bit. 8a minus 2bx. And then what do we have for constants? I see a plus 2a plus 4b and minus 2c. Okay, and that should equal what we have here, 2x squared minus 3x plus 6. Okay? Okay? And from that we see that the minus 2a must equal 2. Minus 2a equals 2. All right, any guesses what a would be? Okay, so a must be negative 1. Let me do it somehow a little bit better than that. And this implies that a is equal to negative 1. Okay? And we have that if you put in a is minus 1 here, then you get minus 8 plus, no. Okay. Minus 8 minus 2b must be minus 3, right? By that? Right here is your x term here, 8a minus 2b, but a is minus 1, so it's minus 8 minus 2b has to equal to minus 3 over here. So let's add 8 to both sides, and you get 2b is equal to 5, or negative 2b is equal to 5, so this would be b is equal to minus 5/2, I think. Is that what you get? Okay. All right. And then at the very end, we have a 2 times a minus 1, so that would be a minus 2 minus 10, because it's plus 4 times b, and the 2 will go in the 4 twice, so that's a minus 10 minus 2c is equal to 6, right? Now, I think let's add those two together. You get minus 12. So minus 12 minus 2c is equal to 6. And I'm going to rewrite that divide by 2, minus 6 minus c is equal to 3. Add 3 to both sides, subtract 3. Add c to both sides, subtract 3 from both sides, and you get c is equal to minus 9. I think, right? And let's see, sure enough, that's what they get. So our particular solution is I need more room. I'll do it right up here. Our particular solution, yp, is equal to minus x squared minus 5/2 x minus 9. Okay, there's our particular solution. What is our general solution then? All right, I'm going to have to erase something here. I've stretched it as far as I can. Okay, I think I'll get rid of this because we've already used it. I can't get it to erase though. There we go, finally. Slowly it's erasing, and get rid of that. I think I can do it now. So our general solution, y is equal to the characteristic solution, c1 e to the, I'll write it the way the book does, I'll change this around, minus 2 plus root 6 x plus c2 e to the minus 2 plus root 6 x. Yeah, I'm changing around to do the way the book did. It's the same answer. Okay. Minus x squared minus 5/2 x minus 9. There is our general solution. Okay. Does that make sense? Do the homogeneous equation first, ignoring the right-hand side, putting a 0 in its place. Come up with their characteristic solution, which used to be our solution for that one. Okay? Then, pick a particular solution you think might work in generic terms, and then run it through the left-hand side, make it equal to the right-hand side, find out what those constants are going to be, and then that becomes your particular solution, and then combine the characteristic with the particular, and you got it. All right. Okay to erase? This is the method of undetermined coefficients. We didn't know what they were, but we figured them out. Okay? So let's do example 2. Find a particular solution of this one. Y double prime minus y prime plus y is equal to 2 times the sine of 3x. Okay? Now notice here they didn't say solve that differential equation. They just said find the particular solution of that. Okay? Now, what would be your guess of a particular solution? And guesses do count pretty good here, so guess well. If you remember back what our choices are, polynomial's not going to do us a bit of good with that sine function, is it? So let's forget polynomials. Your exponential function, not going to do you a bit of good with that. So let's forget exponentials for now. The other two types were both sine and cosine. But since we're going to be taking first and second derivatives, let's not limit ourselves just to sines. We could have cosines in there as well. So let's make our particular solution y sub p equal to, now, again, you need to go with undetermined coefficients a times the sine. Now, time out here. Is the coefficient of x an undetermined coefficient too? No. You can't have any other coefficient of that x except 3x. Okay? So let's leave the 3 alone. The coefficient of this would be, so this would be 3x plus b times the cosine of 3x. Okay? If that's our particular solution, and by the way, that's what they choose too, then let's figure out what our yp prime is. What would that be? Say again? Okay, I'll buy that. A times the cosine of 3x times 3. I'm going to put the 3 out front there. Plus b. Second. You may have been saying right. I'm not hearing right. Yes, it will be a negative. I thought you said plus, so I put plus. I was going to go back and change it if I needed to, which I'm glad you caught. Minus b sine 3x times the 3. Okay, so there's your y particular prime.
So you got the y, the first one, that the a sine 3x plus b cosine 3x. How did you get cosine 3x again? Why? How could you choose the cosine there?
Okay. All right. If you didn't have the cosine here, when you did the derivative of this, you have a cosine here. How are you going to get rid of it? You can't. There's no cosines there. You need that cosine there, so you get a sine here. Okay? And we'll judiciously combine the a's and b's so they go to 0. Remember, we get to do that. Okay. So that's our plan. Let's see if it works. We still got to do one more derivative. What's that? Negative. So, okay, negative 9. A sine 3x. Negative 9. B cosine 3x. All right. Now, let's do what the original function tells us to do. Just do our y double prime, which is a minus 9a sine 3x minus 9b cosine 3x. That's your y double prime. Minus your y prime. Okay, so that's going to be a minus 3a cosine 3x. Minus a minus makes it a plus 3b sine 3x. Got it? Plus, a, the yp is a sine 3x plus b cosine 3x. And this is all supposed to equal 2 sine 3x. 2 sine 3x. All right? Now, let's look at our sine 3x's terms on this side. We got 3 of them, right? So that tells us that minus 9a plus 3b plus a is equal to 2, right? Because you got 1 sine 3x on the other side, and that's coefficient is 2. Do you buy that? Okay. This side is equal to that side, right? This is equal to that. Let's look at all the terms with sine 3x. There's one, there's one, there's one on the left. So factor out this, or forget about the sine 3x, and just look at the coefficients. Minus 9a plus 3b plus a is better than equal to. Right? Okay, now we can combine the two a's, and that gives us minus 8a plus 3b is equal to 2. Minus 8a plus 3b is equal to 2. Okay, now let's deal with the cosines. We got 1, 2, 3 terms of those. Maybe I should have used a different color. What color would you like? Red. Okay. The cosines were this one, that one, and that one. Okay, let's take those coefficients, and what do we have? Okay, wait, let me go back to black. Okay, what did you say? Minus 9b? Let me try. Yeah, minus 3a plus b is equal to 0. You got it. Huh?
Why you make that equal 0?
Because there's no cosine over there, is there? Over there is a 0 cosine 3x. So you have a cosine 3x, a cosine 3x, a cosine 3x, no cosine 3x. So these three coefficients must add to 0. Okay? Now we can combine the b's again to get minus 8b minus 3a is equal to 0. Now that's not in a very nice format to do what we need to do, so let's reverse the signs, the terms here, especially in that last equation, and make this a minus 3a and a minus 8b. Okay. Now, what would we do to solve that? You have several possibilities here. What would you like to do? A little louder? What multiply what together? Okay. Actually, what I would like to do first is get the same coefficient for opposite sign. So I'm going to multiply this one by 8 to make this a plus 24, multiply this by 3 to make that a minus 24b, and then I can add them together and eliminate the b's, right? So we'll multiply the top equation by 8 and the second equation by 3. And that leads us to minus 64a plus 24, goodness gracious, I can't see. My eyes are getting so dry again. Yeah. Plus 24b is equal to 16. And the bottom one says minus 9a minus 24b is equal to 0. Yuck. Okay. Now, why did we do that? What you were suggesting before. Now we add the two together to eliminate the b's. Now, what does that give us? Minus 73a's. I don't like that number at all. Do you? Okay, we don't like it together. Is equal to 16. So A is equal to a whopping minus 16/73. A really pretty number, isn't it? And that's what they got to. Okay, I think. And with that in play, we can calculate what our B is. Let's go back to either one of these two equations here. I think I kind of like that one. Do you? And let's do 3 or minus 3. Actually, I'm going to change that to 3 plus 8b. 3a plus 8b. Let's see what we get. So let's make this pluses here. Okay, sorry. Okay. Whew. Goodness gracious. So that'll be a minus 48, I believe it is, isn't it? Minus 48/79 plus 8b is equal to 0. Right? I can't hear you.
73?
Oh, 73rd. You're right. Where did 79 come from? I don't know. Okay. I'm going to come over here a little ways, okay? So we'll write that as 8b is equal to minus 48/73 this time. Divide both sides by 8. The 8's go out here. You get b is equal to, and 8 will go into 48 6 times. So this will be is equal to negative 6/73. What's that? Okay. And that should be here. And that sure is, wait. Except they got a plus, I think. I'm losing it here. Whew. No, that's not a, it's a plus. All right, because you moved the 48 to the other side. Yeah, it's a positive. Thought it was. I don't know where I picked up that. So anyway, what's your solution? Your particular solution was, with the A being minus 16/73, the sine of 3x plus 6/73 times the cosine of 3x. That's the particular solution. So they let off with the positive 6/73 cosine 3x minus 16/73 sine 3x. All right. Now they have a little paragraph at the bottom. Sort of worry when they sneak these in. As we mentioned, the form that we assume for the particular solution y sub p is an educated guess. It is not a blind guess. This educated guess must take into consideration not only the types of functions that make up g of x, but also, as we shall see in example 4, the functions that make up the complementary function y sub c. And the previous one we did, okay, and even in this one, if we went and did the right-hand side, we just come up with a polynomial. Your auxiliary function would be polynomial. You come up with e to the something, and that doesn't interfere with these at all, okay? But sometimes they can't. So we're going to do example 3 next. Any questions before I move to example 3? Okay. I think that I need to go get something. My throat is... All right, let's move back on to, example 3. Now, the title here is Forming YP by Superposition. Okay? Solve this. Y double prime minus 2y prime minus 3y is equal to 4x minus 5 plus 6x e to the 2x. Uh-oh. Okay. This looks a bit different. Why so? What's different about this one than the previous two that we looked at? Any differences? Example 1 had a polynomial to the right. Your homogeneous part is going to produce only exponentials. Okay? No sweat there. Example 2, now we didn't have to do that one, but it also had a sign to the right, and the left hand, the homogeneous part, was only going to produce exponentials. No conflict there. However, on this one, this is going to produce exponentials. That one's got to have polynomials and multiple exponentials, okay? You see the 6x e to the thing, so boy, this is going to be a little more involved, okay? Now, how do you reckon we start? Homogeneous part, and what would that be? Y double prime minus 2y prime minus 3y equals 0, okay? And then you come up with your M equation, auxiliary equation, which is M squared minus 2M minus 3 equals 0. And what would that give you? Hint, hint. M, what did you say, M minus 2? No, M minus 3 plus 1. Okay. I was trying to listen to what you say. I wasn't thinking. Okay. Is that right? Let's make sure. M squared plus M minus 3M is minus 2M minus 3. Yeah, that's right. So what would that give you as a characteristic solution? Oh, okay. Let's go on and solve for M's. M equals 3 and negative 1. Okay, so your characteristic solution would be C1, 3x, C2, negative x. There's your characteristic solution. Okay? Now, what's a little bit interesting about this is neither one of these e's are anywhere close to what that e is. That's e to the 2x, these are e to the 3x and minus x. So I don't think we're going to have an issue necessarily with that. But we'll see. Okay? There's plenty of time to go. What would you do next? What would you do next? So at least make a guess at a particular solution. YP. What would be a good guess for it? AX plus B plus at least a C X e to the 2x, and I'm wondering if we might not need a d e to the 2x. I don't know. Let's not do anything too rash yet and see what we've got here. Okay? Now, I don't know why they left off D, okay? I really don't. They went from C to E. And I guess there's some reason for that, but one YP would be AX plus B, which we got, and this another YP would be a CX e to the 2x plus E to the 2x. Why not D? I mean, oh, I think I do know. In the next section when we do, and we're not going to do it, but when we do an abbreviation, if you turn over a few pages from here, on page 149, you'll see an annihilator come up, and you see operators, and they use D as an operator. So that may be why they're going to leave it off here. So just to be safe, we'll do that too. We'll change that D and make it an E. It looks sort of silly here because we're not going to run into that here, but because it's there, we'll do it. Okay. Now, I wrote it as one particular solution. They wrote it as two. Okay? And I guess it keeps it a little simpler if we keep them separate. So rather than do this, we'll do a YP1 of that one and then do a YP2 of this one. I'm not sure there's no reason to do it, but why not? The book did it, so we'll do it. That's your YP2. Okay? What's that? They just separate them into two. And there's no real problem with doing that. So now we go back and take our derivatives of our y sub p. Yp1 prime would be A. And Yp1 double prime would be 0. Okay? Yp2 prime would be, let's do it. What would that be? Yeah, that's fine. Cx. Yeah, a 2 on the outside. Yeah. Okay, I was just waiting for you to get there. Okay. 2cx e to the cx. That's one half of a product rule. What's the second half? You did the first time derivative of the second, so now we do the second, e to the 2x times c, isn't it? Derivative of the first times the second plus the second times derivative of the first. Anyway, that's what it is. Okay, that's the first term. Now the second term would be plus two e to the times e to the 2x. Okay. We still need to do a second derivative. Y p2 double prime. Again, we got a product rule here, so let's do that. For c x e to the 2x, that's the first half of the product rule, plus, okay, it has an e to the 2x in it. Do we have anything else in it? C. Okay, I didn't hear you if you said it. Okay, so the first one is your 2cx times the derivative of the second, which would be 2e to the 2x. So that's our 4cx e to the 2x. And the second half of that would be your 2c times e to the x, and that's what we got. But then we have, this one would give us this one would be, derivative of that would be another 2c e to the 2x, right? Okay. All right, let's do this one first. Okay? Product rule. The 2cx times the derivative of this would be 2e to the 2x. That's 4cx e to the 2x. That's this one times the derivative of that. Plus, derivative of this one, 2c, whoops. Yeah, 2c times e to the 2x. So that's where this one came from. Okay? Okay. Then we do the derivative of this one. And that would be another 2c e to the 2x. So that gives us a total of 4c e to the 2x. Okay? So just to save on some space here, I'll just change that to a 4. Okay? And now we got the last one, which is plus 4e e to the 2x. That's your y double prime. All right. Now what we're going to do now is plug in your y double prime for your P1 into this equation up here. So that's going to be 0 minus 2y prime, which is a minus 2a. That's this one here, right? Minus 3 times your y P1, so that's minus 3ax minus 3b. And that's supposed to be equal to 4x minus 5. Just that part. Right? You see what we did? We did the y double prime, which was 0, minus 2 times the y prime, which is minus 2a, minus 3 times the y P1, which is minus 3ax minus 3b, and that's supposed to equal to the polynomial part, 4x minus 5. Okay? So let's combine like terms here. This gives us a minus 3ax minus a 2a plus 3b. I don't know if that's the best way to do it. I'm doing it that way. And that's equal to 4x minus 5. Okay? Well, obviously here, minus 3a should be equal to 4, right? To get the x coefficients the same. And a 2a plus 3b is equal to 5 to get the constants the same. Right? Okay? Well, let's do here, this gives us a is equal to minus 4/3. Right? And unfortunately, that gives us a minus 8/3 plus 3b is equal to 5. If you add 8/3 to both sides, 8/3 plus 15/3 is 23/3. Yeah. So 3b is equal to 23/3. So b is equal to 23/9. I'm not really loving this too much, are you? Yeah, but that's what we got. Where? Yeah. Okay. I may have dropped a sign somewhere. I don't know. Okay. Whew. We got that part. So let me write it down what we've got. Our YP1 is equal to there it is. Okay. Your A is minus 4/3 x, and your B is plus 23/9. Okay. Yes, that is our YP1. Oh, what a joy. We've got to somewhere here get our YP2 done. And let me erase some stuff so we can. I just got to figure out where to erase it. Okay, I don't think we need this anymore. We've used it. And I think we've used everything here we need. And we've already used this and found what we need there and there. But let's not erase any more of that yet. And we've already used this, so I think I will erase this. Okay. We got our particular solution 1. Okay. Let's do our YP2. So the Y double prime here, from down here, I'm going to write it up here, is a 4cx e to the 2x plus 4c e to the 2x plus 4e e to the 2x. I'm going to group those two together, okay? They're just constants, okay? That's our Y double prime. Minus 2 times your Y prime. So help me keep up with this. Yes, that's where I'm heading. Minus 4cx e to the 2x minus 2c e to the 2x minus 4e e to the 2x. Right? Minus 3. Yeah. Minus 3, and here's your YP2. C x e to the 2x minus 3e e to the 2x. And that's supposed to all equal 6x e to the 2x. Right? Think so. Okay. Oh my goodness gracious. So let's get all the x e to the 2x coefficients together. There's a 4c and a minus 4c. Oh boy. And a minus 3c. And that's supposed to equal to 6. I think I got them all, didn't I? There's a 4c from here, minus 4c from there, and a minus 3c from there. And that's it. So, 4c minus 4c, I think I can add those together. That goes to 0. So this gives us c is equal to negative 2. If I'm not mistaken, right? Which is kind of a nice thing. No fractions anyway, so that's okay. Now, let's do the constant term ones. Okay? In other words, the ones without an x in them. And the c, remember, is a negative 2, so 4 times a negative 2 would be a minus 8 plus 4e plus 4, because minus 2 times minus 2, minus 4e, happened again, didn't it? Minus 3e, and that's all supposed to equal 0, I think, right? Well, here's a 4e minus 4e, that adds to 0. So this is a minus 4 minus 3e is equal to 0, meaning 3e is equal to minus 4, e is equal to minus 4/3. Okay, if that's the case, then our yp2 is going to be negative 2x e to the 2x minus 4/3 e to the 2x. Okay? And then, finally, what is our general solution? Y is equal your characteristic solution, which is c1e to the 3x plus c2e to the minus x plus your particular solutions, the first one being there it is. Make it a minus here. Minus 4/3 x plus 23/9 minus 2x e to the 2x minus 4/3 e to the 2x. I think that's it. Let's see if I can find if they have an answer here. Boy, did they avoided writing the total answer, but let's see if we can piece them together. Y is equal to, I think I've got it, maybe. C1e to the minus x, I just reversed the order, plus C2e to the 3x, it doesn't matter which one you call C1 and C2, minus 4/3 x plus 23/9 minus, and then they group these together, minus a 2x plus 4/3 times e to the 2x. Yeah, that's the same answer. Done. Okay. 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 It looked like at the end they just sort of ran around in circles for a bit there, but they came up with the same thing. I take it from the zipping I hear that it must be close to time to go. So we will pick up with example 4 next time. What a terrible way to begin. A glitch in the method. The next example illustrates how sometimes the obvious assumption for the form of YP is not the correct assumption. So it looks like next time's going to be, okay, not going to quite get it right the first time, probably. Okay? So then we'll move on from there. And we will do, let me give you a few homework exercises. I think you can do some of the odds 1 through 25. Okay? And why don't you stop there and we'll do the rest of those later. Okay? And if you run into any other glitches, just stop there. We'll work on the glitches next. Good deal. Thanks for hanging with it. Let me first end this.